Okay, next we're going to look at a question that involves the relationship between height and time. It could be a rock being thrown from the roof of the building. It could be a rocket being launched, as it is in this example. I think I've given questions where I'm being shot out of a cannon, so you get the gist. Okay, so I'm going to go ahead to my screen, or pardon me, whiteboard here, and we'll look at number 2. Okay, so in this one says a model rocket is launched from an elevated platform after 15 seconds. Okay, so let's get going here. We've got time in seconds. We've got height in meters. Okay, launched from an elevated platform. So that in itself is very valuable because that tells us that it's not being launched from the ground. From an elevated platform, okay? I'm going to add that there because I know parabolas are symmetrical and it makes me feel better. After 15 seconds, the rocket reaches a maximum height of 1,600 meters. Bingo. They're handing me the vertex on a silver platter. After 15 seconds, the rocket reaches a maximum height of 1,600. If they had just said after 15 seconds, the rocket reaches a height of 1,600, this would look a lot different. But the fact that that is the max height is them telling me, hey, here's the vertex, okay? It lands on the ground after 32 seconds, okay? Oopsie. And so that doesn't look like an ordered pair, but I'm about to make it into an ordered pair like that. Because if it's landed on the ground, it has a height of 0. Okay, now, you know me, I need to label to get myself organized. If this is the vertex, this is my H and K. This is the only ordered pair I know right now, X, Y. I could find this ordered pair, but let's make sure I don't need to. No, because part A, it says determine the equation of the relationship between the height of the rocket and the time in vertex form. So if I'm working with vertex form, I'm not really all that interested in this 0. Okay, so very similar to the last question we did. Vertex form looks like that. I have an H, I have a K, I have an X, I have a Y. This is the guy I'm interested in. Let's go. Y is 0. A is unknown. X is 32. H is 15. Squared, don't forget him. Very commonly made mistake. K is 1,600. Okay, I need to isolate A. You go away and become negative. Okay, 32 minus 15, I believe, is 17 squared. Okay. So negative 1,600 is equal to A times 289. Again, times, very commonly made mistake. Kids try to subtract this from both sides. These are being multiplied and the opposite of multiplication is division. It's been a long day. Okay? And my final answer is... Oh, that can't be reduced at all. Ooh, ugly. Negative, oh, you can't even see that, I'm sorry. Negative 1,600 over 289, okay? Ugly numbers are numbers too. This is another very commonly made mistake. People will do all the work, all the heavy lifting to get the A value, and then they forget to give me the final answer. So remember, vertex form, you need to plug in your A, your H, and your K. I'm gonna go ahead and do that on another board. Can you see this? Yes, you can. Y is equal to negative 1,600 over 289, X minus 15 squared plus 1,600. They didn't ask me to do this, but just for the sake of practicing my transformations, reflection in the x-axis, vertical stretch, because that's greater than 1, of 1,600 over 289, horizontal translation 15 units to the right, vertical translation 16 units up. Now let me have a look at part B. Okay, in part B, they're asking me to convert this to standard form. Okay, again, recopy this term, not ready for it yet. Recopy that term, not ready for it yet. We need to square this binomial. When I square a binomial, I square the first term and that goes first. I square the last term and that goes last. That middle term, I multiply those guys together. So x times a negative 15 would be a negative 15x. And then I double that to get negative 30x. Okay? Now I'm going to use the distributive property to distribute this nasty guy into all three of these terms. Okay, when I distribute, negative 1,600 over 289 into all three of those terms, I get this. And yes, I understand that these are absolutely nasty numbers, but it's okay because you're just gonna let the calculator do the heavy lifting for you. You're gonna use that fraction button. Okay, the very last step I have is to collect like terms right there. Yuck. Okay. Plus 102, 400 over 289. Okay, so believe it or not, this is the equation of the quadratic relation in standard form. Okay, and then if you remember correctly with what felt like an hour ago, this was the equation of the quadratic relation in vertex form. This is modeling the path of that rocket, okay? So the rocket, if we go back to our diagram, was launched from a height that we didn't know. After 15 seconds, it reached a maximum height of 1,600. That word max tells me vertex, and then it hit the ground after 32 seconds, okay? A couple of units ago, when we had this information, we didn't know what vertex form was, so we would be using factored form and zeros to try to come up with an equation. Now we have another alternative. Okay, part C says solve for the height of the platform using a different method, okay? And so I apologize, I should have said this a second ago. When we converted to standard form, this nasty number at the end represents the y-intercept, okay? Some of us really don't prefer to work with fractions, so let's go ahead and convert that to a decimal, okay? It's approximately 354, okay? So it was launched from a height of 354 meters. I can tell that because one of the good things about standard form is it gives me the y-intercept. I don't have to work for it, okay? This particular question said, can you get to the y-intercept? Can you solve for the height of the platform without using standard form, using a different method? So what I'm going to do is go back to vertex form. There we go. And we learned this, there we go. We learned this in grade 9. The y-intercept is really just the ordered pair we get when we let x be 0, okay? So this is a nice alternative. If you don't have standard form in front of you, you absolutely can still solve for the y-intercept just by letting x be 0. Make sure we follow BEDMAS here. So BEDMAS tells me I have to do what's in those brackets first, which would be negative 15. Okay, now I have to square it. 225 plus 1,600. Now I got to multiply those guys together, and you bet I'll be using the fraction button on my calculator. Oh dear. Okay, hold on. Negative 1,600 over 289 times 225. Huh. Well, that's interesting. Okay. For some reason, I can't enter this as a fraction, and it's getting late, and that's not the point of this video, so I'm just going to default to decimals. You'll notice we got the exact same answer that we got when we looked at the standard form of the quadratic relation. Okay, so it just shows you multiple ways of achieving the same answer, which is a really good trick to use to check your work if you have extra time during an assessment. Okay, I'm going to come back to this diagram for the last part of the question, part D, which asks us to express the relation in factored form, okay? So when we first mapped this out, when they gave us the vertex, it made sense to use vertex form, but we absolutely can use factored form. We just need the zeros. Right now, we only have one of the zeros. So we know that parabolas are symmetrical. The distance from here to here is 17, which means the distance from here to here must also be 17. If I'm hanging out at 15 and I go 17 to the left, this ordered pair is negative 2, 0. And now I'm in business. I just have to relabel these. So these are no longer going to be my x, y, and these guys are no longer going to be my h and my k. This is going to be my x, y. This is going to be my r, and this is going to be my s. And what a beautiful throwback to factored form. So Factored form looks like this. Okay, I've got everything labeled, so let's just start plopping in to get the A value here. We know what the A value is supposed to be, but I just kind of want to show you the entire process. So Y is 1600. A, X is 15, X is 15, and now positive 2, negative 32. Remember, when you're in the brackets, you're being lied to. Okay, let's scoot this up. 1600 is equal to A. We've got 17. We've got negative 17. 1600 is equal to A times negative 289. Divide both sides of the equation by negative 289. And look at, we get that same A value back. Okay, so in order to write this guy out in factored form, we've got Y is equal to negative 1600 over 289, X plus 2, X minus 32. Okay? And again, it's just a nice way to look at the connection between all three forms of the quadratic relation.